Good afternoon, guys. Is the audio clear and the screen is visible?
Yes, sir.
Okay, so today we'll discuss about one of the experiments in your design lab, which is the seventh experiment, which is known as the governors. You have studied about the governors previously, I guess. So these are why it is used. What is the principal reason behind the usage of the governors? Anyone? What is the reason behind the governors, man? Why do you need governors? Vinay?
Yes, sir.
So why do you need a governor?
To balance the system.
To balance the system. Okay. Gopal Krishna.
Sir, to lead in front of you.
Okay. Vaibhav.
To increase the speed, sir.
Increase the speed. Okay. Manisha.
Sir, yeah, to maintain the speed of an engine.
Exactly correct. So that is the word has to be used. Either it will not increase the speed, rather it will not just decrease the speed, but it will maintain the speed. That means in the sense, if you fix the governor to be operating for 50 kilometer per hour, what happens if the vehicle starts moving at 60 kilometer per hour, 10 kilometer per hour ahead of the speed set by the governor? What happens? The governor automatically cuts down the fuel which is entering inside the cylinder. So thereby controlling the speed of the vehicle. So it regulates the flow of fuel inside the cylinder, taking into care the speed which is or by which the vehicle is moving in the road track. Okay. So how this is being obtained is because of the centrifugal forces, and we shall see how it actually a governor works in this particular experiment. So in this experiment, we will be drawing the characteristics of the governors. How does it move with respect to speed? How does the sleep variation occurs with respect to speed and all? So there are many types of governors. So there are VAT governor, Proel, Portal, Hartnell, or different types of governors are there. But for you, in your lab experiments, you'll be having only two different governors. The one is the Porter governor. The second one is the Hartner governor. The major difference being one is the Porter governor is a dead weight governor, and the Hartner governor is an inertia governor, where it uses a spring for its operation. So let us see how these governors work and how to draw the characteristics of these governors. Let us see one by one. Okay. Yes. So this is the governor. Hope you can see that. Yes, the video is being played now. So whatever you are seeing now is a Porta governor. You can observe at the center of the governor, the dead weights are being placed, which is nothing but the Porta governor. So once the required setup of the governors is being done, what you have to do, you have to use the dimmerstat to increase the current flowing to the motor, thereby increasing its speed. So as and when your governor starts rotating, what happens to the sleeve? The sleeve moves upward, okay, because of the centrifugal forces which is created by those masses which are rotating. Because of the centrifugal force, your entire sleeve will starts to lift up. And what is your experimentation consent? What readings you have to take in this particular experiment? In sense, for every 10 mm height of the sleeve, for every 10 mm raise of the sleeve, what is your speed that you have to note it down. Suppose initially it was 100 and, initially it was 10 mm. You have to note down the speed. It has increased to 20 mm, height of the sleeve, increased to 20 mm. Note down the speed parallelly where it is. Similarly, you can use the scale, particular scale, to grab the readings. And if it has reached 30, note down the speed, 40, note down the speed, and 50, note down the speed. Only this reading you have to take from the experimentation. All other will be given in the form of the observations to you. Okay, this is a simple experimentation setup. So this is for the Porter governor. If you want for an Hartnell governor, you have to change the experimental setup, which I will deal it once I look into the calculations. Okay. Next, so we shall look into the calculations now. So this is the Porter governor. As I said, the centrifugal force which is created by the masses which is rotating pushes up the sleeve. Okay, it pushes up the sleeve because of the linkage which is attached. This is how it works. And the readings what you take is this thing. For 10 mm rise of the speed, what is the, for 10 mm high rise of the sleeve, what is the speed? 20 mm rise of the sleeve, what is the speed? 30 mm rise of the sleeve, what is the speed? 40 mm rise of the sleeve, what is the speed, and so on. So that is the only reading. So this is the only reading, the speed reading you are going to take from the experimentation. 0.718 kgs is nothing but the dead weight which are you imposing onto the sleeve. That will be known because you yourself will be imposing on that. Let us look into the calculations now. Calculations are very, very easy. Okay. So X would be your this thing, right? The moment of the sleeve, 10, 20, 30, 40, and 50. Correspondingly, you have to calculate what is the height of the governor, where H is given into H naught minus X by 2. Substitute X as 10, 20, 30, 40, and 50. You'll get H1, H2, H3, H4, and H5 as such. That is 105, 100, 95, 90, and 95. So these are the readings we'll get, which is the height of the cover. Next, you have to calculate the angle of inclination of the arm, which is alpha, which is nothing but the cos inverse of H by L. In the previous reading, you have calculated H1, H2, H3, H4, and H5. Is it? So L will be given, that is the length of the link, that is 125, will be given in the form of observation. So when you substitute H1, H2, H3, H4, and H5, correspondingly, we'll get alpha 1, alpha 2, alpha 3, alpha 4, and alpha 5. Note down the readings and keep it aside. Next is the radius of rotation. For the radius of rotation, the formula is 50 plus L sine alpha. You have calculated the value of alpha 1, alpha 2, alpha 3, alpha 4, and alpha 5. Substitute it. So corresponding will get R1, R2, R3, R4, and R5. Note it down and keep it aside. Next, angular velocity. See, for every 10, 20, 30, 40, and 50 rise of the sleeve, you have noted down the speed, is it? And that could be in the RPM, is it? Now you want in the RPS. What you will do? You will divide it by 2 pi by 60. That you want in radius per second, rats per second. So just convert the velocities into angular velocity by multiplying it by 2 pi by 60. You'll get omega 1, omega 2, omega 3, omega 4, and omega 5. Tabulate them. Next is centrifugal force or the controlling force, which is given by m omega square r. So m is common for all the 5 readings. Omega, you have different values, that is omega 1, 2, 3, 4, and 5. And r is also different for different 5 readings, that is r1, r2, r3, and r4 and r5. Substitute the corresponding values, so you'll get FC1, C2, C3, C4, and C5. So tabulate all the results, what have you got, in the form of a tabular column as shown here. So H values you have tabulated, speed values you have tabulated, alpha values, R value, omega value, and FC value we have just tabulated as such. Using this particular tabular column, what you're supposed to do, you are supposed to draw a graph. What are the coordinates for the graph? The first graph you have to draw as the speed versus the sleeve displacement. Sleeve displacement is what? 10, 20, 30, 40, and 50, right? Speed, you already noted down in the form of observation, so you can just draw a graph like this. The second graph you are supposed to draw is the radius versus the controlling force. So radius R1, R2, R3, and R4 and R5, you have just calculated, just tabulated. FC1 to C5, you can tabulate down the x-axis. Thereby, you can draw this particular graph. So number 1 is speed versus displacement. Number 2 is radius versus force. And that ends your experiment. So it is as simple as that. Any doubts in this experiment? Any doubts? The next one being the Hartnell government. Hartnell is very much similar to the Porter governor. All the procedure is same. For every 10, 20, 30, 40, 50 sleeve height, you have to take the speeds. What are the speeds? Same procedures, same calculations, everything is same, except you have to change the setup, okay, that you can visualize here. This is the Porta governor. So this is the Hartnell governor. See, you can visualize that. The dead weight is being replaced with a spring over there. Okay. Any doubts, guys, in these two experiments in the sense, same experiment with a different setup, Hartnell and Porta? Any doubts?
No, sir.
Understood. If there are no doubts, we shall end the session, man. Understood experiment, everyone?
Yes, sir.
Okay. Okay. Prakash Nayak. Next is Akshay Singh.
Present, sir.
Abhay Kumar.
Present, sir.
Akash.
Present, sir.
Yes, Akash. Akash. Akash KN.
Present, sir.
Akhilesh. Aman.
Present, sir.
Ankit.
Yes, sir. Yes, sir. Present.
Okay. Next is Bharatyan. Bhushan Alwa. Chinmay.
Present, sir.
Yes, sir. Chinmay present.
Alban. Gopal Krishna.
Present, sir.
Gino Sunny. Joyston Fernandez. K.M. Ansar. Manisha. Manoj. Manthan G. Shetty.
Present, sir.
Viraj. Next is Sabir.
Sir, Jabir, present.
Okay, Sabir. Mohammed Shamas. Faisal.
Yes, sir.
Zamil.
Sir, Manisha present, sir.
Yes, sir.
Where were you, Manisha, when I called your name?
Sir, I lost network.
Okay, okay. Zamil.
Yes,
And
sir.
again, K. Nishant. Nishant Raj.
Yes, sir. Nishant K is present, sir.
Okay. Nishant Raj. Okay. Pavan. Pradeep Kumar.
Yes, sir.
Pradyumna. Ravish Prabhu.
Present, sir.
Royal D'Souza. Ronson.
Present, sir.
Ronson.
Present, sir.
Ritika. Sampath. Sanjay.
Yes, sir.
Sanket. Sanket. Sharanappa.
Present, sir.
Shravan H. Shetty.
Present, sir.
Shreyas. Siddharth K. Surya. Sunesh. Sushant.
Present, sir.
Sir, Shammas present, sir.
Sushant is there, okay.
Shammas.
Shammas, where were you, man? I called you.
Sir, it got disconnected, sir.
Sushant.
Yes, sir.
Sushant.
Sir, Shammas present, sir.
Shammas, I marked it.
Okay, sir. Okay.
So Nagendra K.
Okay, Nagendra K marked. Sushant.
Sir, Sushant.
Thank you, sir.
Sushant, we marked, man. To fail.
Sir, Elbun.
Hey, where were you, man, when I called you, all of you?
Sir, disconnected, sir.
Everyone has the same thing.
Your voice breaking, sir, little bit.
Acha. Elban, what's your USN?
038, sir.
Okay, mark.
Sir,
Fine,
Ankit.
Sir, Gino.
Hey, all of you, wait. Those who have missed the attendance, wait until last minute. To fail, Vaibhav.
Present, sir. Whoever present.
Okay, Vignesh. Vinay.
Present, sir.
Vishal. Akhilian.
Yes, sir. Akhilian. Present, sir.
Akhil Shetty.
Yes, sir.
Sripati. Nitin Kumar. Next is Pawan Kumar. Prajwal Yammar. Raghavendra Yu. Sandesha.
Yes, sir. Sir, Sandesh. Yes, sir.
Okay, Shraddha Shetty.
Present, sir.
Subhananda.
Yes, sir. Present, sir.
Arjun G. Shetty. Hemant Kumar.
Present, sir.
Prakash Naik. Okay, guys.
Sir, Prakash Naik. Present, sir.
Okay. Prakash Naik, I've marked it.
Sir, Ankit. Ankit.
Yes.
Come one by one, man. First, Akash is there.
Yes, sir. 014.
Next, Ankita. Ankita, I have marked you. Next,
Okay, sir. Thank you.
Sir, Bharat.
Bharat. Number. Bharatian. Okay.
030.
Okay, marked.
Okay, sir. Thank you.
046, sir.
Gino. Marked.
Thank you, sir.
Sir, Hemant.
Number.
043, 16 mm.
16 ME.
043, Hemant Kumar.
Okay. I have marked you, no. I have marked you.
Okay, thank you, sir. Sir, 407.
407. Sandesha, I have marked you, man.
Sir,
told you
last
attendance,
last
right?
class I was present, sir.
Last class I have marked you present.
Sir, present, sir.
Last class we were present, man. But the thing is, you have missed almost all 1, 2, 3, 4, 5, 6, 6 labs. Okay, only 2 labs you are
Sir,
present.
Vignesh sir told 0% in lab. So
I
last
know.
class I was present.
Last class you are present, man. 2 classes you are present. Okay.
Okay, sir. Thank you, sir.
Yeah.
Sir, 409.